Hello students here. Let's start out today. Let's start our discussion regarding the chemical kinetics only. I'm already discussing about chemical kinetics. Chemical kinetics is nothing but the branch of science which deals about the speed, velocity of a chemical reaction. In this session, we are going to discuss about the how temperature will influence the rate of chemical reaction. I'm saying once again how temperature will influence the rate of chemical reaction. We are going to discuss in today. And today we are going to discuss the most important equation, nothing but Arrhenius equation only. The scientist name is Arrhenius. He has given some systematic way to represent the chemical reaction speed, velocity of chemical reactions only. So look at here, students. Let's start here. Next one is Arrhenius equation only. Okay, most look at first we are going to discuss about the how temperature will influence chemical reaction only. Most of the chemical reaction accelerated, increase the speed by increasing temperature only. Once again, I'm saying most of the chemical reaction is related by the increasing temperature. It means the speed of a chemical reactions are increases with increasing temperature only. Suppose I'm just want the cooking of the food. Suppose I want to prepare food material, then if I use very less heat, it takes more time to boil, more time to cook. For suppose we increase high temperature, the what happen the product will be easily forms. The cooking process happen very easily only. One point I want to mention very clearly only, whatever the chemical reaction we take in the reactant molecule, the solid state, liquid state, gas state, they will take part a chemical reaction. Each individual molecule has certain amount of energy that is called energy of the molecule. The energy of the molecule depend upon the potential energy plus kinetic energy. Okay, kinetic energy because of the momentum only. What happens when temperature increases, kinetic energy of the molecule increases, speed of the molecule increases, collisions increases, they release the product only. Clear? So suppose I was just want to mention here very clearly. Okay, when temperature increases, number of collisions increases. Okay, speed velocity of increases, so product also increases only. Temperature increases. Okay, temperature increases, kinetic energy of the molecules also increases only. I'll give an example, get very clearly. Suppose look at here the decomposition of nitrogen pentoxide. Decomposition of nitrogen pentoxide. Sorry. So decomposition nitrogen pentoxide at 50 degrees Celsius. I'm taking at 50 degrees Celsius for decomposition nitrogen pentoxide required 12 minutes time. What is mean T half means here? For suppose I just take 1 gram of substances. In this 1 gram of substance become to 0.5 grams. How much time is required? That's called a T half. Generally, T half is used for the radioactive elements only. Half lifetime. This is also called as a half lifetime only. Once again, I'm saying half lifetime is the amount of time. Just generally the time required to consume half of its substances. Suppose I'm just taking 1 kg of ice is there, no? I 1 kg of ice become to half kg of the ice. How much time is required? That's called half lifetime only. T half also mentioned, T50 also they mentioned. Both are correct only. For decomposition nitrogen peroxide at 50 degrees Celsius, 12 minutes are required. Half lifetime 12 minutes required. For suppose decomposed nitrogen pentoxide at 25 degrees, it required 5 hours. Remember, temperature is decreases, time also decreases only. At 0 degrees Celsius, it required 10 days for complete decomposition of nitrogen pentoxide. It clearly indicates here that when temperature increases, rate of a chemical reaction increases. Students, the most important thing is in our syllabus, we are going to discuss about the volumetric analysis. The titration of the oxalic acid versus K-manover. Okay, oxalic acid versus K-manover is there, no? This titration is used for the oxidation reduction reaction. This reaction titration is happen at 70 degrees Celsius. At low temperature, this reaction takes place very, very slowly only. Very, very slowly only. From this one, we got one clear idea is that when temperature increases, rate of a chemical reaction is increases. Okay, next one is here. Look at the we'll go for next slide is then for look at the here for just mentioned for homogeneous reaction. Homogeneous reaction means both reactant and product are single phases, either solid, either liquid, either gas only. Rate and velocity of a constant of a reaction get appreciated doubled. What they want to say, when increase 10 degrees Celsius, when increase 10 degrees Celsius temperature of any chemical reaction, the rate of a chemical reaction becomes 2 or 3 times more. 2 or 3 times more only. That's called mentioned there. The ratio of the rate constant for a reaction at two different temperature, which difference by 10 degrees Celsius is called temperature coefficient only. What temperature coefficient? Look at here the KT only, here also KT. They add 10 degrees centigrade more. For suppose here temperature KT1 they are taking observation. After increased temperature they are taking observation. They just notice the value is then here the roughly 2 or 3 is coming only. Answer very clearly, whenever if you increase 10 degrees Celsius, the rate of reaction is increased by double or twice only, triple only. Okay, most of the condition will take 2 only. Let's have next one is there here. Look at the Arrhenius equation only. The scientist Arrhenius here the rate K is rate constant. Look at K is rate constant, velocity constant, speed constant. A stands for Arrhenius constant. Pre-exponential constant also they will call as well. Here next one is EA stands for activation energy. EA stands for activation energy. T stands for absolute temperature. Temperature you must always take in kelvins only. R is called universal gas constant. R is universal gas constant. According to Arrhenius equation, K rate constant K is equal to Arrhenius constant e power EA by exponential power EA by RT. Look at remember this is K is constant. A also constant. K depend upon the temperature only. Look at here, whenever temperature is increases, activation energy is decreases only. Whenever temperature increases, activation energy decreases. Whenever activation energy decreases, the reaction takes place very easily. The reaction takes place very easily. Let's have here, it can look at the initially I'm taking the hydrogen gas and iodine gas is there. Whenever hydrogen gas, iodine gas react together, the molecules react together, they form a one product. Before the formation of product, one intermediate state is there. What intermediate state? What happens here? Initially, the bond between the hydrogen breaks. The bond between the hydrogen iodine will forms. So what happens here? The hydrogen iodine bond is forming. Iodine bond is breaking. Here hydrogen iodine bond. So what happens at a particular time is there? They easily forms a product only. According to Arrhenius, the rate of the reaction can take place only when the molecules of hydrogen and molecules of iodine collides to form an unstable product. Whenever these two molecules are collide, they will form intermediate product. This intermediate product is unstable, then only they gives a product only. If intermediate product is not formed, the reaction will not be takes place. Okay, na? This is said by the Arrhenius only. This is said by the Arrhenius only. I'm saying very clearly, whenever look according to collision theory also, whenever reactant molecules are react, they form one intermediate state. They'll give the product only. Okay. Look at students, a very graph is there here, very important one graph is there here. Look at the mention is the graph, very important. Here potential energy is mentioned. I said no way, molecules having some amount of energy, they have taken potential energy and reaction coordination. Nothing but reaction proceeding. In this direction, reaction takes place only. Suppose look at I'm just taking here the hydrogen iodine molecule is there. Hydrogen molecule is there, iodine molecule is there. These two molecules contain some amount of energy. Okay, that's they have some amount of energy. Whenever these two molecules want to form a product hydrogen iodide, they must be cross this barrier. They must be cross this barrier. This barrier is called as a, look at here, this is called activation energy only. Look at here, suppose just imagine here when these two molecules collide, they got this activation energy. They can easily travel from here to here. When they travel here to here, they form an intermediate state complex only. What is C here? This is a C. This is a hydrogen bond is only. So what intermediate complex, they finally leads the product. They finally leads the product only. One point remember students here that whenever this is a reactant molecule A, this is a B is a product only. Whenever then look at this is difference energy is in delta H difference energy. When the difference energy value is negative, this reaction is exothermic reaction. Exothermic reaction means if any chemical reaction gives energy to the outside, then it is called exothermic reaction. For suppose this is value is coming here, this value is coming here. Suppose look at here, this value coming here, red color line is value is coming here. When compared with reactant A, B molecule having more amount of energy. So this reaction is the endothermic reaction. This reaction takes energy only. This reaction takes energy. This reaction gives this is exothermic reaction only. Look at here, when now just imagine here the line is there here. Look at the below the line is coming means no exothermic reaction. Above the line is coming means endothermic reaction. Above the line is coming means endothermic reaction. So remember here this is called activation energy. This is called activation energy. Okay, the total energy is there from here to here is there no total energy ET, total enthalpy change. They mentioned from here to here total enthalpy change they will call. This is called activation energy. Activation energy only. So next students, the next have some important one is then here. I said very clearly, according to Arrhenius equation is then what they are saying now, if any, according to the collision theory, if any molecule want take part in a chemical reaction, they must have some amount of energy. Okay, they must have some amount of energy. Look at here what they mention here, that the scientist name is Boltzmann. He want to calculate the potential energy of the individual molecule. Okay, potential energy, just make sorry, kinetic energy of the individual molecule only. What has taken here, individual molecule in chemical reaction doesn't have fixed amount of energy. Some molecule have 10 kilocalories of energy, some molecule have 15, some molecule 20 only. He has taken the maximum probability. Maximum probability means if you take the fraction of molecule having energy, fraction of molecule and kinetic energy of that molecules I have taken. When they draw a graph here, the graph look at here, when just consider from here to here. So this point is there, no? From this point is there, no? So here molecules are there, some molecules having some highest amount of energy. That called most probable kinetic energy. Most probable kinetic energy only. So what happens there, the most probable kinetic energy, then these molecules are ready to take part in chemical reaction. The molecule having less probability chemical energy, they never take part in chemical reactions only. They never easily take part in a chemical reactions only. So according to Maxwell, what you want to say means here, so individual molecules, look at the all molecule doesn't have any fixed amount of energy. Look at the all molecule doesn't have any fixed amount of energy. To want to know the properties of the individual molecule is very difficult. So you want to calculate the molecule which having highest amount of kinetic energy. That's why you want to predict the behavior of the large number of molecule. According to them, the distribution of the kinetic energy may be described by the plotting a fraction of molecule versus kinetic energy. By this equation, you have found the most of the molecule having kinetic energy. This one is there. Look at next one is after increase in temperature. Look at there, just consider fraction of molecule, the kinetic energy. I said very clearly, when temperature increases, kinetic energy of the molecules are increases. Look at the before increase in temperature, the kinetic energy is like this manner. It means that the most of, look at in this graph is there, no, most of the molecule having less amount of energy. So what happens when I increase temperature, the graph is going to backside is there, no. Look at the value is increases. It means that the more number of gas molecule having highest amount of kinetic energy. Highest amount of kinetic energy means they will take part in a chemical reaction. It clearly indicates here that whenever temperature increases, kinetic energy of the molecules increases, speed of the chemical reactions are increases. That's nothing but they are going to say here. Clear? Okay. Next one said the next one is that here increase in temperature of the substances increases the fraction of the molecule only, which collide with each energetic energies greater than the activation energy. From this equation, you got very clear only. Whenever it increases temperature, activation energy increases. When activation energy increases, the total number of fraction molecule having the activation energy more than the activation energy, they will easily take part in chemical reaction. It clearly from the diagram that is there now, the curve T plus 10 degrees increase in temperature only. The curve T plus 10. Okay, this is the curve. Okay, this is the curve T plus 10. Okay, what is T plus 10 here? The area shown in the fraction of the molecule having energy equal to or greater than the activation energy. Get double leading to the doubling of the rate of chemical reaction. What they want to say is that when temperature increases, the speed of chemical reaction increases. Look at the roughly the value is then, look at the roughly the value is then it become double, more product will be forms only. So what is Arrhenius equation is given? K is equal to Arrhenius constant, rate constant. K is equal to rate constant. Rate constant K is equal to A into E power E minus ART. E stands for activation energy. R stands for universal gas constant. T stands for temperature. Mathematical explanation only. Okay, first one is this equation is there. I want to do integration only. Naturally, integration K is equal to integration A, okay, and EA by RT. Okay, integration EA by RT means look at E comes first only, no. Okay, what you get here? Integration K is equal to minus EA by RT plus ln A. I want to draw the graph in between the K and T. I want to draw the graph between the K and T. Let's have national Arrhenius equation. Look at the area. Arrhenius suggests that a simple relationship between the rate constant temperature. Arrhenius given the how the rate constant K and temperature. When temperature increases, what happens there? Here the rate constant value depend upon this product only. Temperature decreases, increases, activation energy increases. Activation energy decreases. Activation energy decreases, the rate of chemical reaction is increases only. So here the A stands for Arrhenius constant, T exponential constant, K stands for velocity constant, R is a universal gas constant, E is activation energy, T nothing but absolute temperature. T nothing but absolute temperature. Look at students, I said no graph I want drawn now. Look at the integration of k. Look at the natural integration, not log base 10. So integration of k1 is equal to a by rt natural logarithm a. I want draw the graph between the k and t. Why I am doing? They are both are interrelated only. Activation energy also constant, universal gas also constant, Arrhenius constant only. So what happens when I draw the graph here? Look at the integration of k versus 1 by t. Minus value, minus value means what will the line will comes downward. Okay, no? If you take a slope is there, no? If you take the slope value, what is the slope value? Minus EA by R. Minus EA by R only. Okay, this is the equation only. Okay, this is Arrhenius equation only. Look at the temperature T1. Look at the, suppose I'm just taking the integration of K1. I'm taking the temperature T1, rate constant value is K1. Okay, why means mentioned T1, K1 means both are depend upon each other only. Temperature increases, okay, temperature increases, look at the K value decreases, K value increases, temperature decreases only. Look at this equation of temperature T1. Look at the, I want to take the temperature kinetics value, temperature T2 only. At temperature T2 only. T2 what is the K2 is equal to EA by RT2 ln A. Look at the remember students the K1 T1, K2 T2 only. Look at the integration of K2 is equal to minus EA by RT plus log A. Look at the here functions the here K1 and K2 are the values of the rate constant at temperature T1 T2. At different temperature, the rate constant value is given. At given temperature T1, rate constant value K1, temperature T2, rate constant value K2 only. What I want subtract. I want subtract here the suppose here 2 minus 1. 2 minus 1 only. So what if there is a integration of K2, integration of K2, integration of K1, integration of K1 is equal to, look at there, minus integration of A is equal to minus integration of A. Both minus only, no, both will be cancelled only. So what you get the EA by R T2 minus EA by RT1. EA by R constant value. Clear? EA by R is constant only. So EA by R is emitting constant only. Look at here, I'm taking here. Look at here, the just mentioned here, the mentioned here 1 by T1 minus 1 by T2. T1, T2, I want LCM is there, no? Okay, I want to take LCM T1, T2 is equal to here. What do you get that T1, T2 will get here, T1 will get. T2 minus T1. So look at the students, this is natural logarithm. I want convert into logarithm base 10. Logarithm base 10 means what you do? You have to multiply with 2.303. You have to multiply with 2.303. So that's why you log K2 by K1 is equal to EA by 2.303 or 1 by T1 minus 1 by T2. Okay, log K2 by K1 is equal to, look here, log by K2 by K1 is equal to EA by 2.303 or T1 T2. Look at the LCM I'm taking, T2 minus T1. This is nothing but a Arrhenius equation. Arrhenius equation says that one is the how activation energy changes with rating the temperature, and has given relation between the rate constant temperature also. He has given relation between the rate constant temperature. Look at the equation is there now. Here on the integration of both sides is the mention K1 is equal to K is equal to K1, T is equal to T1, K is equal to K2, T is equal to T2 only. Logarithm based on K2 by K1 is equal to E by 2.303 or 1 by T1 minus 1 by T2. Logarithm equal K2 by K1 is equal to E by 2.303. You got T2 minus T1 by T1 T2. E stands for from this equation E activation energy can be calculated. Activation energy can be calculated. I am saying very clearly in this session we are going to discuss about the if you increase temperature, how activation energy will be changes. How activation energy will be changes. Let students say what is the activation energy? According to this concept, activation energy reactant does not pass directly to product only. Means here that before having this activation energy, reactant molecules are never converted to product only. Arrhenius suggests that before reactant molecules must collide each other, okay, by absorbing a minimum amount of energy is called activation energy. Minimum amount of energy is called activation energy only. It means here the, look at it, means here the, so before forming a product is there, they must be collide. After collision they must gain some amount of energy to cross the barrier only. So look at it, this is graph, you'll get very clear only. So whenever hydrogen and iodine molecule want a product, they must be collide each other, they must be cross this energy barrier. This energy barrier is called as activation energy only. Unless crossing this barrier is there, the molecules are never convert into product only. They never ever convert into product. So what is my activation energy? The minimum amount of energy is required for the collision between the molecules to be effective collision, called energy of activation only. Okay. For suppose I want a very clear simple word is there, no? If you want any molecule or want to convert product, they must have certain amount of energy, that's called activation energy only. I will get one clear one idea. Suppose you want to clear the NEET and IIT JEE as a board examination only, you know what I mean, there some activation, some motivation is required, that's called activation energy only. Students, let's have most important thing is effect of catalyst only. What mean catalyst here? Catalyst is a substance which increase the rate of reaction without take part in chemical reaction. Or else if the catalyst is involved in the chemical reaction, they form a weak bond with the reactant and they give the product only. Clear? The catalysts are two types. One is positive catalyst which increase the rate of reaction. Speed the way increase the reaction. Next, negative catalyst, that is decrease the rate of chemical reactions only. Clear? The use of catalyst provide an alternative path for the reaction by lowering of activation energy. It means here it decreases the activation energy and makes the reaction possible. How it is possible means look at here. Look at suppose this is the potential energy, this reactant molecule. The reactant molecule want to become a product only. They must go without catalyst, they must go for this path. This path means more amount of activation energy is required only, no? If I add a catalyst here, look at there, they'll go for this path. They'll go for this path, they'll convert into product only. When they are converted into product, both equation you can see very clearly. When you use catalyst, the amount of activation energy decreases. The amount of activation energy decreases. So look at here, these two graphs you can mention it there. Look at here from here, look at here from here to here, the reaction path more catalyst only. In the absence of the catalyst only. This is nothing but in the presence of the catalyst only. Energy of the activation energy. Look at the energy of the activation energy. Then suppose here energy of activation energy is more here. Energy of the activation energy is more, but here energy of activation energy is less only. Look at the energy of the activation energy is less, but here energy of the activation energy is more. So what happens there? The catalyst, it does not take part in chemical reaction, but it decreases the activation energy. It decreases the activation energy only. Suppose look at here mentioned this is a potential energy. Look at here whenever the chemical reaction takes places, when you add a catalyst, it will go without catalyst, this reaction go for this path. After adding the catalyst, this reaction go for this path only. Whenever the molecule of acid very clear, reactant molecule and product molecule having less amount of energy, that is exothermic reaction. If the product molecule have more amount of energy, it's endothermic reaction only. Here delta E nothing but change in energy. Delta E nothing but change in energy. Delta E nothing but change in energy only. Actually, a catalyst itself does not use in chemical reaction, so small amount of catalyst is sufficient. Look at for suppose I want to bring the more large change of number 1 million molecules I want to react. I need only very small 1 gram or 1 milligrams, milligrams are required. It's sufficient only. After this completion of the reaction, the chemical composition of the catalyst remain unchanged. Unchanged for a catalyst, specific catalyst only. Okay, no? The chemical composition remaining unchanged only. Look at here, this is the example very clearly. Reactants energy. Look at reactant molecule, a product is there, no? The reactant molecule reaction path with catalyst. This is a path with catalyst. This is the path without catalyst. This is a path without catalyst only. So next one is here I said very clear activation energy. Already we discussed about the activation energy only. Look at there, yeah, energy of activation is equal to. Look at the energy of activation is equal to depend upon the temperature only. Its value depend upon the temperature only. Look at different temperature, different activation energy will come here. Okay. For suppose energy of activation depend upon the nature of the reactant only. Depend upon nature of reactant. So how is depend upon nature of reactant means I will say one clear idea. Gases react very fastly when compared to solids. Liquids react very fastly when compared with the solids only. So what happens when our physical state changes, rate of reaction also changes only. When the physical state changes, rate of reaction also changes only. So next one is the collision theory. Most important thing is the collision theory only. What is the collision theory here? Collision theory, what said here, the very collision theory important one is, according to this theory, a chemical reaction takes place only collision between the reactant molecule. It means two molecules collide, then only reaction will take place. Unless collision of molecule, no reaction will take place. But not all collisions are effective. Means effective collision, ineffective collision. Whenever a molecule proper orientation, they use product. Students say that whenever A and B is there, no, they collide, they properly oriented, they collide, they gives product. If they're not collide each other, they never gives the product only. Okay, no? Whenever both the collision is takes place, this is called effective collisions only. If they're not collide, it doesn't take place, it's ineffective collisions only. The colliding molecule must possess some sufficient kinetic energy cause of chemical reaction. Means I said very clear, minimum energy required to take part in chemical reaction. Once you want to clarify the board examination, you must have the basics. If you doesn't have any basics are there, no, we cannot do anything else. Next one, the reactant molecule must collide with proper orientation only. Orientation also important. Orientation also important. We'll discuss properly. Orientation also important only. Look at the next one. The next one point is there here. Look at the next one is there now. Hence, Arrhenius equation says that one before formation of product, the molecule must be activated by some amount of energy. I said very clearly. This one you got very clearly. Suppose I will say one example. Hydrogen gas and oxygen gas never react to room temperature. When you give the temperature more amount temperature, they both react. They will give product. Look at the once again. Hence, Arrhenius says that one before formation of product, colliding molecule must be activated by absorbing a minimum amount of energy. So they want take part in a chemical reaction. How much heat is required? That is but activation energy. Clear, no? So that they can pass over the activation energy barrier. They gives product only. Look at this is the potential energy. This is reactant coordination only. This is reactant molecule. Whenever this reactant molecule gains some amount of energy, then only they will convert into product only. I will some other example also. A simple example. You want to prepare any curry. If you supply minimum amount of temperature, then only the what are the ingredients they will mix properly, they give product. Unless you are providing that sufficient amount of heat, no chemical reaction will be takes place, no product will be formed only. Clear? So next one is then if the reactant molecules collide with insufficient amount of energy, they cannot pass the energy barrier. They cannot pass the energy barrier. So insufficient energy means they never cross this barrier. They never cross this barrier only. Clear? So next point is that here however if the reactant molecules collide with sufficient energy, they can pass over the energy barrier and get activated and convert into product only. Look at here the A and BB molecule is there, BB molecule is there. The both are collide properly, proper orientation, collision is happen. They gives the product. They gives the product. Look at here, this is called intermediate state. This is called intermediate state. AB bonds are become weak, AB bonds are become strong only. Okay. Next one is this threshold energy or minimum energy necessary to allow the reaction occur called as activation energy. So look at it, very very important. This threshold energy or minimum energy necessary to reaction occur, that's called as activation energy only. Look at this is activation energy. This is called as activation energy only. Next one is thus energy of activation in the minimum energy required for the collision between the molecule to be effective. Okay, the molecule must have the minimum energy only. Slow reactions having highest activation energy only. Slow reactions having highest activation energy. Clear? More activation, so higher. Suppose here the activation energy low only, the reaction happen very fast reactions only. Suppose ionic reactions are there, they have activation energy very less. I want to very clear what is activation energy, what activation energy means here. I'll see one small example. Suppose I just want to say here, if you want to clarify the NEET and IADG examination, you have some knowledge must be required. That knowledge is about activation energy. Clear? As temperature increases, effective collisions increases, hence activation molecule increases, the reactant rate of reaction increases only. Clear? Temperature increases, effective collision increases, rate of reaction increases. The magnitude of activation energy depend upon the nature of the reactant. Activation energy depend upon the nature of the reactant. Means gases have less activation energy require, solid require more activation energy, liquid have moderate activation energy. Clear? So next one is there here. Okay, transition state theory, activation complex is there, no? What is transition state theory means? I said very intermediate state is there, no? Because this is transition state theory only. This is transition state theory. Okay, this theory applied to the gas or liquid phase reactions only. It is very complicated theory only. According to this theory, before reacting molecule changes into product, they form a transition state or activated complex, which is unstable and decomposes only. Okay, this is unstable and decomposition. You'll get one graph here. Suppose you look at this one is there, here carbon monoxide, okay, and nitrogen dioxide both react together. Both react together, proper orientation. They have some activation energy they got. They convert it, they form a one intermediate state. This is called intermediate state. Look at here, carbon, oxygen, oxygen, nitrogen, oxygen, nitrogen and oxygen. This is nitrogen, oxygen, oxygen, carbon, oxygen. After formation product, what happens there? The nitrogen dioxide is forming. Look at there, because carbon dioxide is forming, nitrogen monoxide is forming. Look at here, this is carbon, oxygen, nitrogen, oxygen and oxygen. This is two oxygens are there. One of the oxygen atoms are moved from the nitrogen to oxygen only. This is a product only. Clear? This is a product only. So here go for the next one. Is look at here, this lead to formation of activated complex only. What happens initially? AB molecule is there, BB molecule is there. They react together, form a one intermediate state, unstable state is there. No, this intermediate state brings the product. AB one product, AB one product. Clear? So look at here, for example, you consider the X plus Y plus Z is the displacement reaction. Just remember, they form a Z only. Same, these are displacement reactions only. Here displacement here. Nitrogen dioxide is there, you become nitrogen monoxide. Carbon monoxide is there, you become carbon dioxide only. Look at here, look at the form of intermediate state. Look at the area, X is there, no, Y Z product reactants are there. So X Y Z activation complex is forms. This breaks into the X and Y and Z. This breaks into the X and Y and Z only. I said one important thing is there here discussion about the Arrhenius equation. Rate is equal to ZAB into EA by RT. ZAB into Z nothing but A. Okay. So according to collision theory, what happens in the collision theory, rate of reaction is directly proportional to the Z nothing but here the collision constant. Z nothing but a collision constant. Here Z stands for the collision frequency constant of the A and B molecule. A and B molecule, they will collide, they form product only, you know, that's why they mention Z only. E nothing but E minus A by RT. E minus A by RT, general constant only. Suppose look at here, just imagine, I will say here the one point, important point is there, no? Okay, effective collision. The collisions between the reactant molecules result of the product is called effective collision only. Along with the effective collision, here Arrhenius factor, there is a proper orientation of the reaction also required. What is the proper orientation? You have some doubt is there. Suppose look at the methyl bromide want become methanol. What happens? This hydroxide molecule will react. They will give the product to this one only. But this reaction happen two process only. One is bromine ion is coming, hydroxide ion coming. The both are coming same direction is there. No. What happens? It takes look at the both will be repulsed. No product will be forms. Suppose the hydroxide group is coming back side and bromine leaving this side is there. No, look at no repulsions are there. They form one intermediate state. They give the product on. So what happens there? For any collisions also there is a proper orientation also required only. But a collision theory they have taken is then reactant molecule like a hard sphere. Reactant molecule like hard sphere. General reactant molecules not hard sphere. They have specific shape will be there. Regarding shape is there, no, they mention one factor is called P. Rate is equal to P nothing but orientation factor, Z nothing but frequency factor of A and B, E stands for EMI RT. Okay, this is clearly explained about the. I want to very clearly for any chemical reactions happen, the molecules must be proper oriented and collide in the proper direction. They give the product only. This is one example only. Formation of this product. If they both are oriented proper direction, improper direction is there, no, then no product will occur. Proper direction is there, they form an intermediate state, they give the product only. This is nothing but regarding the chemical kinetics.